Hello and welcome to Final Jeopardy! Our competition has been riveting so far, but as always, it all comes down to this. For our final question of the day, what is the title of today's class? 30 seconds on the clock. Good luck. Bum 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 ba da 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 dum bum bum ba da dum bum 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 ba dum bum 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 bum. Did you guess solving quadratic equations Redux? The correct answer is, of course, what is solving quadratic equations Redux, playing by Jeopardy rules today in our first class of Unit 9. Now at the end of Unit 6, we saw how to use square and cube roots as inverse operations when solving polynomial equations. Back in Unit 7, we learned how the deceptively powerful zero property could help us solve certain polynomials by factoring. And coming off of Unit 8, we made a point of connecting both of those methods to the process of graphing, as it was the way that we went about identifying the x-intercepts of our parabolas, right, our graphs of our quadratic equations. But you'll also hopefully remember that we still have those pesky prime polynomials, bars, from Unit 7 that we still haven't fully addressed. And in Unit 9, that's our goal. We're taking those off the back burner, finally addressing the elephant in the room. We want to try our hand at solving some equations with prime quadratics. Say, for example, that I want to solve something like x squared minus 2x equals 1. Well, let me make it more obvious for you that this guy is prime. Say that I want to get a 0 on one side and try my hand at the zero property. Well, that would give me x squared minus 2x minus 1 equals 0 if I subtract 1 from both sides. I dare you to find a factored form of this guy on the left. X squared minus 2x minus 1, it's a quadratic trinomial, so it's definitely going to be something times something. At the front, x times x. At the back, I would need two numbers that multiply to -1 and add to -2. Well, I don't know any numbers that satisfy that criteria, so I'm at a bit of an impasse. Here's our goal, to unstick ourselves from this. But first, since a strong building can't stand on a weak foundation, let's just do a little bit of a review to make sure that we feel good about the solution strategies we've encountered thus far. Say, for example, that I want to solve y squared equals 49. We know two different ways to solve this equation here. What are my two strategies, and can you use them to find me some values of y? Go! Alrighty. Well, for my first method, back in Unit 6, we saw that we could use some square roots as inverse operations to cancel out some squares. So if I take my equation, y squared is equal to 49, the opposite of a square is a square root. So if I take the square root of both sides, I'm left with that y on the right, or on the left, and on the right, square root of 49 is 7, but of course if I take a square root, either the positive or the negative version will do. I'll add in my plus or minus. But I also saw in Unit 7 that I could factor and use the zero property to identify some values as well. So if I take my y squared equals 49, in order to use the zero property, well, that requires me having a 0. So let me subtract 49 from both sides. I hope you don't mind if I don't write out that step. From here, y squared minus 49, well, look at that. Y squared and 49 are both perfect squares. They're joined by subtraction. This guy is a difference of squares. So I'll set up my two parentheses. Difference of squares gives me a difference of signs. One gets a plus, one gets a minus in the middle. At the front, y squared has got to be y times y. And at the back, 49 has got to be 7 times 7. From here, by the zero property, if their product is 0, then one of them must be 0. Therefore, either the y plus 7 is my 0, or the y minus 7 is my 0. Subtracting 7 from both sides reveals that my first possible value of y is -7. And on the right, adding 7 to both sides reveals that y could also be +7. I hope you will agree that both of these solution sets are equivalent. Cool! Let's do a little bit of practice with this. I've got two equations here for you to solve using either factoring or the zero property, right? It's up to you to figure out which one in context makes more sense. Give it a hand. Give it a hand. Give it a shot. That's a better analogy to use. It's not an analogy. It's a saying. I don't know, whatever. Solve your equations. Go! All right, let's do it. I want to solve for m. If 0 equals m squared minus 5m, well, I've already got a 0 on one side. Let's try to factor the other. Notice that both of these have a common factor of m. If I take m away from m squared, that leaves me with one copy of m. Take m away from negative 5m, that leaves me with negative 5. Now by the 0 property, since I've fully factored, if they multiply to 0, then one of them must be 0. So either the m is my 0 or the m minus 5 is my 0. If m equals 0, m equals 0. If m minus 5 equals 0, adding 5 to both sides, m is equal to positive 5. Now I can also be really annoying if I want. In my set builder notation, 0 is smaller than 5, so I could also express my solution set like so. 2 times the quantity u minus 4 squared minus 3 equals negative 1. Well, here I could expand out that u minus 4 squared, but it's going to be way easier for me if I do some inverse operations. Reverse order of operations, let's start with addition subtraction. I'm going to add 3 to both sides. That leaves me with 2 times the quantity u minus 4 squared is equal to 2. Now let's do our multiplication division. I'm going to divide both sides by 2 to reveal that u minus 4 quantity squared is equal to 1. To get rid of that square, let's take the square root of both sides. That's going to leave me with u minus 4 is equal to plus or minus 1 whenever I take a square root, add a plus or minus. Now I've got to do a little bit of splittage. So my two cases here, if u minus 4 is positive or negative 1, then either the u minus 4 is the positive flavor of 1 or the negative flavor of 1. Adding 4 to both sides on the right, or on the left, sorry, reveals that u is equal to 5. And adding 4 to both sides on the right reveals that u could also be equal to positive 3. Again, if I'm being really annoying, here's my set builder notation. 3 is smaller than 5, therefore it comes first inside of my squiggly brackets. Cool! Onwards we go! 2 more equations for you. Take 2 minutes, pause the video, see how far you get. Can you find me some values of n and v? Go, go! Alrighty, let's get her done. So, for the one on the left, n squared plus 7n equals 3n squared plus 6. I could either subtract 3n squared or the n squared from both sides. The general wisdom is that it's easier to factor when there is a positive leading coefficient. So I'm going to subtract the n squared from both sides. That's going to leave me with 7n is equal to 2n squared plus 6. Now I'm just going to subtract that 7n from both sides. I'm going to write it in standard form because, again, writing it in standard form generally makes it easier to factor. We'll say 2n squared minus 7n plus 6 is equal to 0. Now, I have a 0 on one side. Let's factor the other. Notice that this guy is a quadratic trinomial. At the front, I need 2 numbers to multiply to 2n squared. Well, that's got to be 2n times n. So let me flesh out my parentheses over here. And at the back, I need 2 numbers here to multiply to positive 6. Because I have that negative in the middle, I'm going to go with some negative versions. So it could be negative 3 and negative 2, or negative 1 and negative 6. By some trial and error, you should find that the factors should look something like 2n minus 3 and n minus 2. If you don't believe me, feel free to do some metwet to check your middle term. But I believe me, so I'm going to do my 0 property. If these two multiply to 0, then one of them is equal to 0. If 2n minus 3 is my 0, I can add 3 to both sides to get that 2n is equal to 3. Dividing both sides by 2 reveals that n is equal to 3 halves is my first option. If n minus 2 is equal to 0, I can add 2 to both sides. Here, n is positive 2. If I want to be annoying, 3 halves is smaller than 2, so it's going to come first inside of my set builder notation. 0 is equal to 1 minus 1/9 the quantity 3 minus 2v squared. Same as before, let's do some inverse operations. So I'm going to start with my addition subtraction. Let me subtract 1 from both sides. Here, negative 1 is going to be equal to negative 1/9 times the quantity 3 minus 2v squared. To get rid of a multiplication by negative 1/9, well, that's the same as dividing by negative 9, so I'm going to multiply both sides of my equation by negative 9. Negative 1 times negative 9 is positive 9, and then on the right, I chose that strategically to get rid of that times negative 1/9. This is going to leave me with the 3 minus 2v squared. Once again, I want to get rid of all that stuff in the parentheses, but I can't until I take my square root. The square root of 9 is plus or minus 3, and then that leaves me with the 3 minus 2v on the right. From here, let me do some splittage. So here, my two options, if I'm plus or minus 3, it could be the positive version of 3 equal to 3 minus 2v, or the negative version of 3, which is equal to 3 minus 2v. In both cases, though, I'm going to begin with the same move. Let me start by subtracting 3 from both sides. This reveals that 0 is equal to negative 2v. And then dividing both sides by negative 2, I revealed that 0 divided by negative 2 is still 0. And in the case on the right, I'm going to subtract 3 from both sides once again as my opening move. This is going to reveal that negative 6 is equal to negative 2v. Dividing both sides by negative 2 reveals that positive 3 is the second value of v. So in my set builder notation, I know that 0 is smaller than 3. So here is my solution set. Cool. Now let's up the ante just a tiny bit. Today is mostly review, but there's one thing that I want to show you that can happen when you solve specifically with square roots. Let's take this guy, 3z squared minus 14 equals 10. Now your opening move should hopefully be easy to you, right? I'm going to begin reverse order of operations by adding 14 to both sides. So this is going to reveal 3z squared is equal to 24. Next move should also be pretty straightforward. I got rid of my addition subtraction. Let's do my multiplication division next. So dividing both sides by 3 reveals that z squared is equal to 8. Now, I want to get z by itself. The square is in the way. Let's use a square root to cancel it out. I'm just left with z. Now on the right, I'm taking a square root, so I know that this is plus or minus. But there's a bit of an issue here. What's the square root of 8? Well, that's not a perfect square. So how am I going to make sure that I fully simplify the right-hand side? Take 30 seconds. What can I do with the square root of 8? I'll give you a hint. Think back to Unit 6. Go. And stop. Well, 8 isn't a perfect square, but 8 is 4 times 2. And you'll hopefully remember that the square root of 4, that's something I can do. Fully simplifying here, I can reveal that z is equal to plus or minus the square root of 4, which is 2, times that square root of 2. So plus or minus 2 root 2 is our final answer. Now we know that our solution sets, throwing it back to Unit 6, can also contain some radical expressions. Let's do 2 more just to make sure that this idea sinks in, and then I'll set you free to cry over this. J, 1/4 times the quantity j plus 1 squared minus 5 equals 0. K, 7 minus quantity 3k minus 6 squared equals negative 11. Let's see if we can solve for each of these variables. Again, we might encounter some radicals. Go. Alrighty, to begin, let me start with my equation on the left by adding 5 to both sides. Here, 1/4 times the quantity j plus 1 squared is equal to 5. Again, I want to get rid of that times 1/4, which is the same as division by 4. Let me multiply both sides by 4. That reveals that j plus 1 quantity squared is equal to 20. Now, once again, I need to take the square root of both sides. Let me make it more obvious that I'm taking the square root of 20. On the left, the square root and the square cancel out. That just leaves me with the j plus 1. And on the right, the square root of 20, right? On its own, that guy is not a perfect square, but 20 contains a factor of 4, which is a perfect square. So we say that j plus 1 is going to be equal to plus or minus 2 root 5. Now all I need to do to get j by itself is subtract 1 from both sides. You may remember by convention, we typically write the number stuff before the square root stuff. So our final answer here will say that j is equal to negative 1 plus or minus 2 root 5. Same thing for k over here on the right. Once again, I want to begin by doing any addition words or subtraction that I see. So we're going to start by subtracting 7 from both sides. So negative, don't lose that negative sign, 3k minus 6 quantity squared is going to be equal to negative 18. Now I can multiply both sides by negative 1 or divide both sides by negative 1 to reveal that 3k minus 6 quantity squared is equal to positive 18. Once again, I'm now going to take the square root of both sides. So 3k minus 6 is going to be equal to plus or minus the square root of 18. Well, 18 is 9 times 2, and 9 is a perfect square. So we've got 3k minus 6 is going to be equal to plus or minus 3 root 2. From here, let me add 6 to both sides, write my inverse order of operations. So 3k is going to be equal to, again, the convention is to write the 6 here first and then the square root stuff at the back. Now I just need to divide by 3. Well, let me divide everything by 3 here. 3k divided by 3 leaves me with k on the left. 6 divided by 3 is 2. And then 3 root 2 over 3, notice that I can cancel out that common factor of 3 in the numerator and the denominator. That leaves me with a final answer of k equals 2 plus or minus the square root of 2.